Understand? Good morning once again. This is Dada Dollar Boazes. I'm going to show you how to use prota for structural analysis, and then we're continuing from where we stopped yesterday. So yesterday, I actually let me just recap on what we did yesterday. Yesterday, I actually showed you how to use AutoCAD to bring in your GA into your software analysis, most especially Orion and prota. They have the same interface. You can use them together. So look at this now. We're able to match property from this existing GA to form a new GA for something that is like a shop. You understand? Now this place now is a shop. Initially yesterday I had 1.5 here. Let me do it again. O offset. Offset. Now O is offset. So offset is like is you want to create a new line from this line. You just want to copy this exact line here, and I want to offset it by a distance. Offset, let me say 1.5 that it was before. Can you see what offset is doing to us now? So that is that. If you want to do create the same line at a distance, you just use offset. You can use copy, fine, but offset is better so that you can input the distance to it as an engineer. So like this now, you can see that imagine that this is shop, a store, the lobby, to walk around to connect the shops together. I could have put my columns here, at this point, and at this other point. But why I did not put it yesterday, I explained that this span is 4.5 meters, and the structural member you're going to use here should be 225 by 450. That's the minimum allowable beam. You understand? So that's a minimum allowable beam I use personally, and I don't think any other person use lesser than that in structures in Nigeria. So we have 225 by 450 beam, and 225 by 450 beam can span up to 5 meters. So why put another column here, another column, another column, another column, another column? Let's save cost. You understand? So that's why I removed this center. This center column, you highlight it, copy, and I'm returning it back there. So as well as I can have my span of slab here like this and other places, I decided to save cost, and I highlight it, E for erase, and you press enter, and then E again for erase, and you press enter. So that is that. Then I copied it, Ctrl C, or click on the screen, go to clipboard, copy with base point, or copy any of the two, but I prefer copy with base point. You have a base point where you copy, you pick the point. So this point now is a reference point from this structure. So this point, you will see the effect when we get there. There is another place where you can do that copy and paste. That is from the icon at the top, clipboard. So you can get your clipboard. This is the clipboard here. You can see the mouse. So this is clipboard paste. This is the clipboard copy. This is clipboard cut. So I took it to another page on AutoCAD, the fresh page. So you can use Ctrl N for that. New file, Ctrl N. So you open, see there already. I remove the grids. I don't actually like the grids there. And then I do my Ctrl V, space, enter. You just click on the point, then you press Z, enter, Z, space bar, E, space bar. Recall that space bar and enter, they do the same work on AutoCAD. So if you are using AutoCAD, I would love you to use your left hand on your space bar, your thumbs on your space bar. Your left hand should be doing the typing, while your right hand is already on the mouse. So it's better to use the space bar as your enter, so you can always type. So now we go back, and then we now imported this into the software for analysis. Let's assume that structure is a 3-story structure. Now I have done the importation of, I have imported the structural members into the software, and edited it and other stuff. So now I want to put the beam. Now if you want to introduce beam, after putting the column, you put your beam and then slab. So I'll show you one or two things here now. Here you come to beam. On the beam you see general 3D and other stuff. So you click on the depth of beam you want to use is 450, while the width is 225 by 450. So you click at the point here, you move, you move, you move, you move, you move, you move. Now press enter or escape. If you want to draw a beam again, you can click on that beam, one of the beams that you have drawn, that's the same beam part you want to use for that point. Right click it and go to properties, and then click at the point where you want to start, and then just drag to the end and click at the end point. It automatically add all the beams. You can see that there are two methods we have used now to add the beam. The first one, we click on one, from one point to there, clicking one point to there, clicking one point to there. The second one, since we know we are going to have a continuous beam along this grid, so I clicked at that initial point, and then I took it down. I didn't even click on all the points. I went to click on the last point, and it came up. So now the next thing, beam again. Let's divide it into panels. Click on it. Click on the second point, and then you right click to escape that point, so that it will allow you to from another point. Let me show you that so that you can understand better. Let's delete what we have done now. I'm not deleting as it's only beam I'm deleting. Properties. So look at it very well, please. First point, second point with left click. Now you want to escape this point. If you had come here now, it will just draw this beam diagonally, which is wrong. So what you should have done is this. What we should have done is see, you click on it, select second point, and then you right click. If you press escape, it will take you back to where we're clicking on beam again, and then but when you right click, the member selection, the action you are doing presently is still there. You understand? It's still there. You don't have to go back and press escape and then go and pick beam again at every point. No, you right click to escape this one that you have drawn last, so that it will allow you to go to the next place to go and do whatever it is you want to do. You right click again, and that's all. So you can press escape now, and you close this beam properties, and then want to do slab. Now on the slab down, we are assuming that this structure is for store when you parking goods. So we have our slab section to be 150 mm, concrete cover 25 mm. Good. And then we go to the load. We come to enter value for the dead load. So for this dead load now is no, let's assume it's 2.5. So this dead load is actually additional dead load that is coming up on the structure, which is partition load and finishes, either tiling and other things. So basically partition is 1.0 and then finishes should be around 1.2. So giving us a dead load of 2.35 is sufficient enough. Then in post load, general domestic load is not general domestic use. is a commercial building. Where we have shops, so bedrooms and motels. Office for general use. Bank shopping areas over 4.0. So we put it this way. So this is a two-way slab. The next thing you have to do is to draw your slab strip. Say slab strip, why? Yes, you have to draw your slab strip now. If you are drawing your slab strip, that's the line that helps you to analyze your slab. So now, this slab strip now, if you want to draw the slab strip, this end is a beam. This end is a beam. Have it together. Now, if you want to draw it, you see this icon here initially means you are starting from inside the slab, which means that if you don't have a beam at this end, or probably you've drawn, I will show you where to use that in our next structure that we are doing, probably in a duplex or a building that has different shapes. But this one that has a straight shape, you don't have to disturb yourself so much. Basically, what you do is start at the start. See at the start here, and analytical strip is what we use for slab analysis. For slabs, suspended slab is an analytical strip, while raft foundation is basically finite element strip. So you click your analytical strip here, and I click at the end. At the start is a beam, at the end is also a beam. So that, press your control so I can give you a straight line, and then you press enter. It's saving the project, just give us a moment. Okay, you can see now. So doing the same thing here, doing the same thing here, doing the same thing here, doing the same thing here. And wait, before we do this, I want to add a feature. I want to add something to it so that you can see. Now, if you want to do a cantilever slab, let's assume that at this side now there's a cantilever here. There's a cantilever here. Let's assume there's a cantilever of 1 meter there. So you go to slab, you come to general type of slab. So cantilever slabs are always type 12. You can see it's type 12, so it's supported at one end only. You click on type 12, you come to B slab, L cantilever, that's the length of the cantilever, and we say, so in this length of cantilever now you put 1.2, 1200, and then you have to input load on it. And most times impose load that you don't have to put at this end, that block wall load. Block wall load. Come back from that. Let me see on this cantilever drawing here. So you click on the start point and the end point, and then you can see now it's showing you where to put the slab. So you now click outside the side you want the cantilever to be. So this is the cantilever slab. This is a cantilever slab. This is a cantilever slab, but we'll not put it here because we have done the slab strip at this direction. For this direction, let's put it here. Now what we'll do is this. We'll delete this so we can analyze. Let me delete these two. Let's draw again. Remember, slab type 12, 150, fine. Cantilevers, L's cantilever, that's the length of the cantilever. While this B slab, that's the span of the slab. But you don't have to input that because you are going to be using your mouse to pick from point to point on your interface. Put it together. So we move again, pick the slab straight. Now at the start of this one, that would be a bulb, that's the end of beam, while the end would be cantilever. So I'm starting to draw it from this end. Where you are starting matters. Press your control and then you end it there. So this section is okay. Now I want to show us the beam wall load. To put beam wall load, we are going to be adding walls to the structure. So you go to edit beam wall load. So what I use is 3.48 for my wall load. That's a unit wall for 9 inches block. That's 225 block. The height is 3 meters. The wall thickness is 0.25. So this 3.48 actually caters for the block wall and the rendering on both sides. You can see that the total dead load is 10.44. Please take note of this 10.44 kilonewtons per meter. So what you do is you copy beam wall load, and then you highlight the whole structure, and then you right click and you put paste beam wall load. So you paste beam wall load on all the beams if you have all the beams to carry the beam wall load. So this is our cantilever now. Let's imagine that we have block wall at this point. Going up, probably this place will be a office at the back office at the back for probably the store or somewhere. Okay, let's imagine that this is a shop. There is walkway at the front. Somebody enters into the store, and then the back somebody just have a small office there, like we have in this chemist and other stuff. So there'll be blocks here now. So since there will be block here, let's analyze for the blocks wall load. So you click on properties. Remember that load we got at the other time, 10.44. So that's what we put at the parapet load, 10.44. Updates. Okay. So for you to see what we have done in 3D mode, you come here, window, arrange window, and then click on this A and B. You can make the plan to be bigger than the model 3D. So you shift it 60-40%. So you can see what I've done now. So this is the parapet load. That green line is a line load for that point to cater for it, to help us get the load better. So the next thing we'll do now is this. After you have input the load and every other thing, so I want us to come to building setup to make it 3-story. So come to building setup, go to insert story. So we are saying we are doing 3-story, and you add 1 for the roof to it, so that makes it 4. So 4, 3 suspended floor. So 2-story 1. Another thing, if you are working on prota, if you are on a floor where you have not copied, you have not modeled like this empty floor like this now, story 3 or story 4, it won't allow you to generate model. It won't allow you to generate model. It won't allow you to copy. You can see now only populated stories can be defined as source for generation. So we cannot do generating model here. That is copying from the first floor we have done now to all other floors. So you rather just come back and click on story 1, and then you now come back again and click on building, and then you now go to generate story, and then from story 1, which is the one you have modeled, you copy to all other models. So from story 1 to story 2, you can see that's copied. From story 1 to story 3, you can see that's copied. From story 1 to story 4. So the story 4 is the roof beam area. So you don't have to input, you don't have to put slab there. please be mindful of what you are removing. It's only slab will remove anything slab will remove them off. So we have it like this now. Then the next thing we do is we reduce our beam wall load. You can see this now. Beam wall load. This beam wall load is too much for roof load, assuming a roof load. So mostly my analysis, I assume a 1 meter or 1.5 meter load for the roof beam load. So this one is 3 meters high. So I go to edit beam wall load for one of them. I reduce this wall height by, let's say, 1 to 1.2 or 1.4 or 1.5, depending on how you feel the load will be for the roof. So 1.5, one of them, and then you click on copy beam wall load, and then you have this, and then you paste the copied beam wall load. You say yes. Are we together now? So once you copy this beam wall load, now you can see that it's really looking. Then another thing I do again is, now depending on the structure, your roof beam should be, and span, your roof beam should be 300. No, it's not carrying much load again. Your roof beam should be 300 depth, 300 mm. So you come here, you select all of them, select all the roof beams. I want to reduce it to 300 depth. So you click on properties, you can see 450, so change it to 300. So everything has been changed to 300 now, and then I close. So now we have everything changed to 300. So what we should do again is this. Now we are good to go to run our analysis. We have inputted the loads, the live load, the dead load, the additional dead load, the cantilever load. We have drawn a slab strip. We have inputted the load, we have done our slab strip and every other necessary thing. So the next thing to do is to run our analysis. But before you run the analysis, I want to show you one or two settings that will guide you in producing a nice result. So you come to settings. Under settings, you see okay, before we do these settings, let's go to analysis and do some setup for analysis. So if you want to go to analysis, you want to run the analysis, you come to building, under building, building, come to analysis rather. So if you want to run the analysis, you come to analysis, under analysis, you see building analysis. So I'm so used to using the icons on the interface, I have to just come back and find the right place for you to use it. But this is the icon. Look at where my mouse is. Look where my mouse is. This is the icon for analysis. This is where you get analysis, and from analysis you go to 3D building analysis. Under the 3D building analysis, you see it has come up now. So pre-analysis is the first thing. Model options, analysis, post-analysis. So under the pre-analysis now, you edit materials. So that's the first thing to do. You edit materials. Even before that settings I was trying to show you the other time. So under the editing of the materials, you change your concrete column grade. That's the strength grade of your strength of your concrete at 28 days when they test it, that you want them to produce on site to run the design to do the construction. So basically in Nigeria, most people don't actually get this 2025. So I'll suggest or advise anybody that is doing structural design in Nigeria to always, if it's a structure you cannot control, that you know that somebody else is going to do it, just give them this 1620. But basically the standard to use in Nigeria is 2025. So we'll use 2025 for the course of this project. Then the strength of your reinforcement, 410. 410 is good. 410 Newton per millimeter squared. And the rebar for concrete column. Now this is a 3-story building, so you are going to be having reinforcement on the ground floor because it's 3-story building, and is this structure we are going to look at now, that we are looking at now. When we run the analysis, you will see some one or two things there. Because this 225 by 225 is a 3-story building and is a block of stores where they will be putting the goods. This 225 on this ground floor will not pass. But nevertheless, let's run the analysis first and get. So 20 mm, 16 mm, and 12 mm for the columns. Okay, 20 and 16 is okay. Don't 12 mm. For the slabs, 12 mm is good. So you click on 12 mm. For the links, that's your sharings. Here you click on select all and then you click again. Are you seeing what I'm doing? I want, instead of me clicking on it one by one, to be on clicking what they put there initially. Instead of me on clicking one by one like this, on checking one by one, I can select all and select all of them. So I will now go and pick the one I want to use, which is 12 mm. So the next thing I do after the slabs, so you have selected the reinforcement type you want to use. Diameters, rebar diameter for column 1620, rebar diameter for beams. So you select all and select. So you now pick for the beam. 16 mm is okay, 20 mm is okay, and 12 mm. I don't want to use 12 mm now, but let's use 12 mm too. Okay, so we go now, press OK. So we go to load combination and then load generation. So you generate the loads, steel and concrete. Okay, so remember, load combination, load generation, so I can generate load. So to give you all these load combinations for your analysis. So then the next thing you do is model options, analysis. You don't analyze yet. So we come back. After that, we come back and come and do our settings. So under the settings, you see beam design settings, story beam. So on this story beam now, this first page, you leave it as this. Second page, you change it. Minimum steel bar reinforcement, maximum steel bar is 20. Then you come to the share links. We didn't check the link very well. You can see now. Come back to this design. Settings, beam design settings, story beams. So now the story beam, check for design, steel bar selection under the parameters, So you change your link. Mostly you can use 300 for your maximum link, but I use 250, that's 10 inches. Steel bar selection, steel pattern 2, steel pattern 3 is what I use. Links, please be mindful of these stuffs I'm doing here. Start up pattern 3, okay, go to containment, then lap inside adjacent support. You can see these changes now. So once your reinforcement is coming from this span, it goes into the second span. Now lap into outside support. You can do this, but I prefer this. So it comes from this span, enters into this. This comes from this span, enters into this. So it laps at the support. So then the next thing you do again is go to Bob Control, click this, go to detailing, beams, use beam insertion. Beam insertion axis as label. So this grid now you can see that A between 1 to 2. So on grid A, between grid 1 and grid 2, I'll show you that sections. So you put span section only. We start every section label in every sheet, which means that all through this one, if you have 20 or 30 beam sections, all of them will follow their self. It's not like you have A1 to 1, A1 to 1, A1 to 1, A1 to 1, A1 to 1. All of them will be numbered separately. So beam 1 will carry A1 to 1, beam 2 will carry A1 to 2, beam 3 will have a different name. So all of them will carry their different names, not the same name. Then you now come to steel bar selection. Here, look at what I'm doing, please. So basically, you change this steel bar notation by, you remove this so that I can give you, are you seeing this change? Yeah. Then shift layer outside support. So print steel bar information should be there. So these are the setup I do here. Then you click on print total links, so I can give you total number of links so that you can guide them on site. If it's 15 links that is there, or 13 links, or 17 links, you know. Then you go to sidebars. This is okay. Then you go to dimensioning. Now this is the most very important place to check. So dimension bulbs, you remove it from prota. Dimension second span, remove it. Dimension slab should be there. Dimension support, no. So another thing is this dimension lap length at the top, dimension lap length at the bottom, remove them. So this is okay like this. So we can move over and save our settings for the beam. So the next thing is comfort settings for slab. Settings, go to slab settings. Now under your slab settings, click on this 12 mm, 200. That's, I want the slab should be 200 mm maximum. Minimum should be 150. So you click view, select this so that it will print as bottom top, top top, and top bottom, not T1, T2, and T3. So that is that. So we are done with the setting now. So you can come back to your model analysis and then run your analysis now. So if you look at this very well, look at what you're saying. You want to run the analysis, you come to analysis. The first thing to do is to do the building analysis. Don't do the column and beam reinforcement design yet. Run the building analysis. If there's a problem, to show you, you correct it before you now go back to. Okay, now I want to run the analysis. Is fine. Let's run the beam and the column analysis for today. So analysis has been done. We want to check the beam first, beam design. So now you can see that all the beam design passed. Cross check one by one by one. Let's close. Click on story. So story 1, these are story 1, these are story 2, these are story 3. Click on story 1. It's a typical floor. So once you select story 1 and you can run the design, you're good to go. So this is Y20, and I'll make it 3Y16. Top is 2Y16. Good. Steel bar pattern 3. Now I would always love to use 2.7. You see the design is okay. Y12. It's good. Y20, okay. Y20. So why I checked this for just first place, because it's a typical floor all through. So the other place I need to come and check is, I just checked for first floor alone, because first floor is the same as second floor and same as third floor. Only the fourth floor I'll come and check the beam because it's the roof beam. So while you're detailing, you can only just extract out the first floor detail and see typical floor details, and you're good to go. So this one, 2Y16 top and bottom all through for the roof beams. Y12 can go. Y12 can go, yeah. Where's better, I'll put it 3Y12 bottom, Y12 top. These are roof beams for story 4. Three bottom for Y12. Hey Bishop. Move 1 minute, we're busy. Okay, that's what you basically do. Just change everything to 3Y12 bottom and 2Y12 top. Thank you so much for today. We'll meet tomorrow as we continue with the. Okay, let me show you 1 or 2 things on the column. Let's press OK here. Let's go to the column. Did it pass all through? 3-story building. Wow, it passed 230. 1 failed. So we'll actually look at the one that failed and why it failed. Column section design. Y16, okay. So we look at the column that failed. Go to this place. Okay, that will be tomorrow, please. Look at everything that is needed tomorrow. 1C. So this is how you correct columns that fails in your structure. 1C1, 1C15. So I actually have to look out for 1C15. Where is 1C15? So is this column here that failed on the ground floor because of the cantilever? So we look at it, column section design, and then we can change to 300 tab 300 or 250 by 250. Let's see. For Y20 passed for it. So everything has passed the columns. Oh. So we move. Thank you so much for joining our class today. See you in the next class. We'll be looking at foundations, part foundation. Thank you.